Assalamualaikum and good day everyone. My name is Johanna binti Johari and today I am excited to share with you the findings of my final year project, which is isolation of Laevifolin derivative from Macaranga Heynei. This project focuses on the fascinating genus Macaranga, particularly the species Macaranga Heynei, known for its diverse and potentially beneficial compounds. Through my research, I aim to isolate and identify different derivatives contributing to the understanding and potential applications of these natural compounds. According to Radcliffe-Smith 2022, Euphorbiaceae is a family of flowering plants commonly known as the spurge family. It is a large family with approximately 300 genera and approximately 7,500 species. These plants differ in size, habit, and ecological adaptation. Euphorbiaceae can be found in a wide range of habitats around the world. They can be found in tropical, subtropical, and temperate climates. The family contains a wide range of plants with varying adaptations to different environments. Next, the genus Macaranga. The name Macaranga is derived from a vernacular term from Madagascar. It is the only genus in the subtype Macaranginae and is known for its large diversity, encompassing around 300 species. The genus Macaranga, which belongs to the Euphorbiaceae family, contains approximately 280 species that range from West Africa to the Oriental region and the Fiji Island. The distribution of Macaranga species can be found in Malaysia's tropical rainforest. In addition, they are also found in New Guinea, Borneo, West Africa, and the South Pacific Islands. They are widely dispersed in both forest and disturbed regions. Several notable Macaranga species are Macaranga Heynei, Macaranga mapa, Macaranga peltata, Macaranga tanaris, and Macaranga calpensis, and many more. Macaranga is a fast-growing evergreen tree that may reach 20 meters in height. The wood ranges from soft to somewhat hard, and it weighs between light and quite heavy. It was therefore utilized in the manufacturing of paper, particle board, and plywood. Aside from that, Macaranga species have been used in traditional medicine by the old folks. In Malaysia, Macaranga was used to treat a variety of ailments. Furthermore, the dried root is used as an emetic, while the fresh leaves are used to cover wounds and act as an anti-inflammatory. Macaranga species have a wide range of pharmacological properties, including anti-inflammatory, antimicrobial, antioxidant, and cytotoxic properties. Macaranga is known to be a rich source of prenulated flavonoids and stilbenoids, which contribute to its diverse biological activities. As I mentioned earlier, Macaranga is a large genus with 300 species in the Euphorbiaceae family that are rich in prenulated stilbenoids and flavonoids, which are known to possess broad spectrum of bioactivities. However, only 15% of them have been phytochemically examined. Furthermore, the phytochemical study on Macaranga Heynei has reported 7 prenulated dihydrostilbenes with significant bioactivities. However, there is limited information on the chemical data of these species. Thus, this study is proposed to further investigate the chemical constituents of Macaranga Heynei, especially Laevifolin derivative, which can further be tested on biological activities. So, this study may provide advancement of knowledge on an underexplored traditional medicinal plant of significance and helps to expand the phytochemical profile of the bioactive components of Macaranga Heynei, which has been relatively limited. Furthermore, this study will also advance understanding of the structure-activity relationship, which may exhibit a wide spectrum of bioactivities and contribute to the health of the community. Thus, this may be used for the development of natural products and pharmaceutical products. There are two objectives of this study. Firstly, to isolate the Laevifolin derivative from Macaranga Heynei leaf extract using various chromatographic methods, and secondly, to elucidate the purified compounds using spectroscopic analysis such as Fourier transform, infrared FTIR, nuclear magnetic resonance NMR, and ultraviolet visible UV spectroscopy. Move on to the chemical constituents of Macaranga Heynei. The phytochemical studies on Macaranga Heynei have revealed the presence of dihydrostilbene compounds. 7 pure chemicals were successfully isolated from Macaranga Heynei leaf, namely menaheneins A, B, C, and D, followed by 3 non-compounds, which are Laevifolins A, Laevifolins B, as well as Macarobiginosin C. The extraction and isolation of compounds from the leaf of Macaranga Heynei begin with the collection, drying, and grinding of the leaf into a fine powder. 2 kg of this sample being used for further processing. This powdered sample undergoes maceration in methanol at room temperature for 24 hours and were repeated for 3 times, resulting in a 300 gram crude methanol extract. The crude extract is then dissolved in a solution of 80% methanol and 20% water, followed by a liquid partition to remove chlorophyll, yielding 50 gram of crude hexane extract and 150 gram of crude ethyl acetate extract. The crude ethyl acetate extract undergoes vacuum liquid chromatography VLC with a hexane and ethyl acetate as the solvent system. This process results in 9 fractions labeled as MH1 to MH9. Approximately 321.10 mg of fraction MHC were subjected to column chromatography. The silica gel in the column chromatography acted as the stationary phase, while the eluent acted as the mobile phase during the purification process. The solvent system used was chloroform and ethyl acetate to avoid two pure compounds, which are MH61 with 27.9 mg and MH62 with 2 mg. Then, these two purified compounds were subjected to spectroscopic analysis, including UV, FTIR, MNR, to establish their structures, concluding the detailed extraction and their purification. Now, let's take a look at the results and discussion part. Compound MH61 with the mass 27.9 mg was isolated as a yellowish semi-solid from the leaf of Macaranga Heynei. The UV spectrum here showed the absorbance of the compound over a wavelength range of 200 to 500 nanometer, with a prominent peak at 215 nanometer, indicating significant absorption in the ultraviolet region. There is also a minor peak or shoulder at 270 nanometer. The absorbance gradually decreases beyond 400 nanometer, indicating minimal absorption in the visible region. These absorptions suggest the presence of conjugated double bonds and a phenol system. The IR spectrum of compound MH61 provides valuable information about the functional groups present in the analyzed compound. The broad strong absorption band at maximum wave number 3427 cm indicates an OH stretch, which is typically associated with alcohols or carboxylic acid group. The sharp peaks at the maximum wave number 2931 cm indicate CH stretching, commonly in organic compounds. The peak at maximum wave number 1619 cm represent carbon-carbon stretching in an aromatic ring, and the peak at the wave number 1455 cm indicates the CH stretching. Absorptions in the fingerprint region below the 1500 cm include the peaks at 1072 cm, which correspond to various COC bending mode. This 1 proton NIR spectral analysis of compound MH61 reveals a complex molecular structure featuring 2 aromatic rings A and B and 3 pentant groups. Ring B exhibit metal-coupled aromatic protons at region 6.56, while ring A contains a single aromatic proton indicated by a broad singlet at region 6.49. The presence of 3 pentant groups was displayed by a series characteristic signals of olefinic protons at region 5.49 to 5.46, while allylic metallic protons exhibits at region 2.97 and 2.69, followed by metal groups exhibits at region 1.36 to 1.22. 2 of these pentant groups appear symmetrically attached to ring A, while the third is linked to ring B. Additional signals of alpha and beta at region 2.77 and 2.6 respectively suggest the presence of saturated 2 carbons bridge potentially connecting the aromatic rings. The 13 carbon ATT NIR spectrum analysis of compound MH61 revealed a complex carbon skeleton with 22 signals representing 29 carbon atoms. There are 4 signals indicated auxiliary carbons at downward region from 140 to 153, while the signals suggested the presence of quaternary carbons are at 140.5 of carbon 1, 133.6 of carbon 1 prime, 131.1 of carbon 9 prime, 129 of carbon 9 and 14, 1279 of carbon 5 prime, and 117.7 of carbon 2 and 6, while there are 6 methyl carbons were exhibited from the signals at 1 to 5.3 of carbon 8 and 13, 1 to 3.1 of carbon 8 prime, 1 to 0.2 of carbon 6 prime, 112.6 of carbon 5, and 100.7 of carbon 4. The metallic carbons were represented by signals of upfield region at 36.6 of carbon beta, 32 of carbon alpha, 28 of carbon 7 prime, and 24.9 of carbon 7 and 12. While 6 methyl carbons appeared at the region 25.1 of carbon 11 prime, 25 of carbon 11 and 16, 17.3 of carbon 10 and 15, and 69 of carbon 10 prime. A doublet signal of metallic protons at region 3.34 of carbon 7 prime correlated with 140 of carbon 4 prime, 127.9 of carbon 5 prime, and 120 of carbon 6 prime, confirming 1 prenyl groups located at C5 prime on ring B. The other 2 prenyl groups on ring A were attached at carbon 2 and carbon 6. Thus, based on the comparison of 1 proton and 13 carbon FPT NMR spectra of MH61 with the literature data by Ahmad et al. 2007, the compound MH61 was characterized as Laevifolin B. Now, let's move to the discussion part for compound MH62. The phytochemical study on the leaves of Macaranga Heynei has successfully yielded compound MH62 with the mass of 2 mg was obtained as pale yellowish semi-solid. The UV spectrum showed the absorption at maximum wavelength of 230 and 218 nanometer. Characteristic of transitions in aromatic systems strongly suggesting the presence of aromatic rings. Next, the IR spectrum of compound MH62 provides valuable information about the functional groups present in the analyzed compound. The broad strong absorption band at maximum 3427 cm indicates an OH stretch, which is typically associated with alcohols or carboxylic acid group. The sharp peaks at maximum 2930 cm and 2866 cm indicate CH stretching, commonly in organic compounds. The absorption peak at maximum 1620 cm and 1457 cm represent carbon-carbon stretching in an aromatic ring. Lastly, the absorptions in the fingerprint region below 1500 cm include peaks at 1072 cm, which correspond to various COC bending modes. The 1 proton NMR spectrum of compound MH62 display on the various peaks that correspond to protons in different chemical environments. The orthocoupled protons of 2' and 6' appear as a distinctive doublet at approximately 6.37 and 2 ppm, indicative of a 1345 penta-substituted benzene ring B. This aromatic system is further elaborated by the presence of aliphatic protons at 7' and 8', which manifest as 2 doublets at 7.37 ppm and 6.85 ppm, suggesting a trans-configured carbon-carbon double bond conjugated to the aromatic ring. A sharp singlet at 5.72 ppm assigned to proton 4 indicates an isolated proton environment likely on the core structure of the molecule. The spectrum's complexity is amplified by the presence of 2 prenyl groups evidenced by a cluster of signals in the aliphatic regions. These include around 3.2 to 3.4 ppm at proton 7 and proton 12 present the methyl line of protons. Singlets at 1.7 and 1.8 ppm of proton 10, proton 11, proton 15 and proton 16 presents the methyl groups, and a multiplet at 5.1 and 5.2 ppm of proton 8 and proton 13 present the olefinic protons. The dihydrodimethylpyran ring contributes further to the spectrum richness, with proton 10' likely corresponding to a doublet at 6.64 ppm and proton 11' to another at 5.7 ppm. The 13 carbon FPT spectrum of compound MH62 displayed 21 signals representing 29 carbons. The oxy area carbons typically appeared in a signal at tongue region 153.56 of carbon 3 and 5, while 6 signals suggested the presence of quaternary carbons at region 140 of carbon 1, 145 of carbon 3', 138 of carbon 4', 134 of carbon 1', 130 of carbon 8', and 128 of carbon 9 and 14. 7 methane aromatic carbons were exhibited from the signals at region 125 of carbon 8 and 13, 122 of carbon 7', 121 of carbon 5', 117 of carbon 2 and 6, 116 of carbon 6', 115 of carbon 2' and 100 of carbon 4. The spectrum shows multiple peaks in this region, particularly clustered around 125 to 130 ppm, which are characteristic of aromatic CH carbons. Methylene carbons typically appear outfield in the lymphatic region. In this spectrum, we can see a distinct peak at 76.02 of carbon 9', which is likely to represent a methylene carbon. Finally, the methyl carbon signals are usually found furthest upfield. The strong peak at approximately appeared at signals 26.93 of carbon 10' and 11', and 25.2 of carbon 15 and 16, which is consistent with a mature group. Thus, based on the comparison of 1 proton and 13 carbon FPT NMR spectra of compound MH62, this structure is close to Laevifolin B, especially on ring A. Furthermore, the meta-couple on aromatic signals also resemble Laevifolin B. However, the parent group at carbon 5' on Laevifolin B has cyclized to dihydrodimethylpyrrole ring, resulting in a new Laevifolin derivative elucidated as Heynei H. As for conclusion, the phytochemical study of Macaranga Heynei leaf has led to the successful isolation and characterization of two prenylated dihydrostilbene compounds known as Laevifolin B and a new compound Heynei H. This discovery enhanced the understanding of Macaranga Heynei's chemical composition and opens up new avenues for research within the Macaranga genus. These findings could also have significant implications for future pharmaceutical research and development. Last but not least, this discovery not only contributes to the phytochemical knowledge of Macaranga Heynei, but also highlights the potential for further exploration of bioactive compounds within the Macaranga genus. Before I end this presentation, I would like to give two recommendations for the future research. Firstly, it is suggested to explore chemical modifications of these compounds to potentially enhance their bioactivities and improve their pharmacological properties. Secondly, continue the phytochemical study on other Macaranga species to identify the more Laevifolin derivative. And that's all from me. Thank you for your attention.